Hello everyone and welcome to my science fair project about using object detection and deep learning algorithms to aid the visually impaired. Every simple task performed with individuals with sight is exponentially more difficult with those with visual impairments, and there's millions of them in the world. Creating a device that helps them perform those simple tasks with ease is the goal of this experiment. So, my question is, can object detection deep learning algorithms be applied to the creation of a utility that aids those with visual impairments navigate difficult environments by identifying objects within their vicinity? So my hypothesis is, if I have a Raspberry Pi running object detection software along with distance analysis and audio output, the data acquired by a camera that's on the user, should be able to apply those object detection and distance analysis and give an audio output of relevant information to the person with visual impairments. So a few of the materials I used for this are obviously the Raspberry Pi 4 with 4 gigs of RAM, the Raspberry Pi camera, the Pi TFT touchscreen, a power bank, and definitely an audio output, so earphones, headphones, or a speaker. So the procedure of this experiment was broken down into a few blocks. So the first of which was Raspberry Pi OS installation, which is the Raspbian version of Debian, and for this project we're using Debian 10 or Buster OS. After that, we're going to establish an SSH connection with our computer and the Raspberry Pi so we can input all of our code from there. Then we're going to install the hardware, so the camera, display, power bank, speaker, all that stuff. Then we initialize the Raspberry Pi, start it up, give it a full system restart, install a few necessary packages we need, and we'll get to the next part, which is the TensorFlow Lite and Pygame, OpenCV, and all of the main object detection and audio output packages. So upon running my experiment and testing my innovation, I found that it runs the software with difficulty and has severe performance issues, running only 6 frames per second and heating up to 70 degrees at times. The good thing is the video stream is consistent and the quality is also good. When the audio output is unavailable, it gives a text output, which is very helpful for those with sight, but not for ones with visual impairments. It also takes a couple seconds to detect objects in its frame, and it struggles when there's multiple objects in the frame, and it does not apply the distance analysis due to the performance issues. The analysis of this project is the large OS file of Buster OS is causing significant GPU load due to all the graphical user interface that's within the OS. Potential fix would be to use a scaled down version of the software. For future iteration of this project, it would be wise to use a pocketable device that we already have, as this Raspberry Pi and power bank combo is very bulky and it's not easy to fit into your pocket. So using a pocketable device you already have, such as our smartphones, it would be very helpful and very convenient for those with visual impairments to run this software. And we could use proprietary software that's already within these phones, such as Apple's core machine learning. The Raspberry Pi also endured difficulty when locating multiple objects, so we would have to dedicate a list of prevalence dictating which object is more important than the other. Conclusion. The innovation produced as a result of the question supports the hypothesis given, but it does not fully fulfill the criteria set by it. It is possible to aid those with visual impairments using a mobile device to run object detection and distance analysis software. But at this current iteration, it does not fulfill the criteria set by the hypothesis, and it is not fully functional and is still a prototype. Thank you so much for watching my science fair presentation.
Window shade. Webcase window shade. Coiled. Computer keyboard. Spacebar. iPad. Notebook.